we now look at properties of radioactive particles. Remember, we have said before that these radioactive particles are alpha particle, that's alpha 42, beta particles, which can either be beta minus or beta plus, gamma rays, so let's quickly discuss them. Number one, we have the mass. Mass of alpha is 4u. So don't go and say that the mass of alpha is plus 4, is 4u. U has a value of 1.66 times 10 power minus 27 kilograms. Mass of beta is 1 over 2000 u. Mass of gamma is 0. 2. Charge. Charge of alpha is plus 2e. E has a value of 1.6 times 10 minus 19 coulombs. Charge of beta, beta minus is minus e, beta plus is plus e. Okay? Charge of gamma is 0. Number 3, identity. What can we liken them to? Alpha particle is the helium nucleus, while beta particle is an electron, while gamma are electromagnetic radiations. Then number 4, ionization. Ionization. Alpha particle exhibit the highest ionization. Ionization is basically the process in which they remove an electron from the air molecules. So as the alpha particle passes through air molecules, because it has a charge of plus 2, it is able to extract electrons and causes ionization in the air molecules. So ionization is highest in alpha particle. Ionization is negligible in gamma particles. In beta is intermediate. Then we talk about penetration, degree of penetration. Alpha particle shows the highest penetration. Alpha particle shows the lowest penetration. Hence, it can be stopped by paper. So it travels few centimeters in air. Why does it show the lowest penetration? Because it shows the highest ionization. So as the alpha particle causes air molecules to become ionized, it loses its energy, and therefore its kinetic energy reduces, so it can travel only few centimeters in air. While beta can be stopped by aluminium. So ionization is higher in beta than in alpha. While gamma can be stopped by lead block. So they have the highest ionization. Then speed. Speed of alpha varies from like 0.01 c to 0.1 c of the speed of light. While speed of beta is 0.99 of the speed of light. While speed of gamma is the speed of light. So speed of light, don't forget, is 3.0 times 10 power 8 meters per second. And don't say that 0.99 of the speed of light is approximately equal to speed of light. No. Because speed of light, this is 3.0 times 10 power 8. And 0.1 of this value is 3.0 times 10 power 7. Okay? So note that. So the speed of alpha varies from 0.01 of the speed of light to 0.1 of the speed of light. While the speed of beta is 0.99 of the speed of light. Why effect on photographic paper? Effect on photographic paper. All of them can be darkened. All of them darkens photographic paper when they are exposed to photographic paper. That is why I wrote yes, yes, yes there. All of them darken photographic paper on exposure to photographic paper. So these are the properties of alpha what? These are the properties of alpha, beta, and gamma rays. Know them so that you know how to use them effectively. Alright? Alright. So all of them darken photographic paper when they are exposed to photographic paper. Now, let's talk about radioactive decay. Before we talk about radioactive decay, let me talk about behavior of radioactive particle in a uniform electric field. If you have a uniform electric field which exists between oppositely charged plate, this negative plate, this positive plate, and you have radioactive particle there, one will be deviated slightly to the negative plate. One is undeviated, while the others shows a range of deviation towards the positive plate. The one that is deviated to the negative plate is positively charged. The one that is deviated towards the positive plate is negatively charged. The one that is undeviated has no charge. The one that is slightly deviated is relatively heavier than the one that is heavily deviated. So we can say that alpha particles undergo slight deviation towards the positive plate, which shows that they are positively charged and they are relatively heavier. Beta minus particle here shows a range of light deviation towards the positive plate. This shows that number one, they have distribution of energy. They do not all have the same energy. That's number one. Number two, they are negatively charged. And number three, they are relatively lighter. Gamma particles do not deviate, meaning that it doesn't experience both electric force and gravitational force. So it's not deviated based on its mass. It's not experiencing gravitational force. It does not deviate based on also its charge. So it does not experience an electric force. So it doesn't have mass, and also it does not have what? Charge. So the first one I want to write is that alpha particles are deviated slightly towards the negative plate. Towards negative plate. This shows that they are positively charged and relatively heavier. Beta particles shows a range of slight deviation towards the positive plate. This is actually beta minus, don't forget that. This shows a range of slightly towards the positive plate. This shows that they are negatively charged and have a distribution of energy. Why do they have a distribution of energy? Because neutrinos and antineutrinos are produced during beta plus and beta minus decay, respectively. So the distribution of energy is one of the things that showed the evidence that whenever beta plus decay occurs and beta minus decay occurs, some other particles are also produced. Those particles were later found out to be neutrinos and antineutrinos. Number 3, gamma do not undergo deviation. This shows that they do not have mass or charge. Therefore, they are electromagnetic radiations. Note this. This is very, very important. All right, go over them effectively. Now, another thing I want to show is behavior of radioactive particles in a uniform magnetic field. In a uniform magnetic field. So if you have a uniform magnetic field and I have alpha particles and beta particles, gamma rays in this region, alpha particles show slight deviation, beta particles shows a range of deviation for the same reason. Gamma are undeviated. So this alpha fall to gamma 0, 0, beta, so I'm looking at beta 0 minus 1. So alpha particles and beta particles, that's beta minus particles, are deviated in opposite direction in the same magnetic field, while gamma are undeviated. So alpha particles and beta minus particles are deviated in opposite direction in the same magnetic field. Gamma are undeviated. So this also shows you that gamma particles do not experience magnetic force. And the reason for that is also the same reason why they do not experience electric force. That's because they do not have what? Charge. Okay? So, let's look at alpha decay. Alpha decay. Alpha decay means that a nucleus AC decays into daughter nucleus Y with the emission of alpha particle with the release of energy. So if this parent nuclei decays into this daughter nuclei and it emits an alpha particle, its nucleon number will reduce by 4, while its proton number will reduce by 2. Now beta plus decay, that's beta 0 plus 1. So if I have parent nuclei AZ and it undergo a beta plus decay to give beta plus, this will be A, this will be Z plus 1. Whenever beta plus is emitted, neutrinos are also produced, which are also referred to as electron neutrinos. And this is actually one of the reasons that showed us, because the beta particle shows a distribution of energy, that shows us that some other particles are also produced. Then later it was discovered that those particles are actually neutrinos. So if a particle undergoes beta plus decay, nucleon number remains the same. Proton number will have reduced by 1. Please take note of that. Proton number will reduce by 1 in order to balance this. Then it's going to now produce the neutrinos. Then we also have beta minus decay. That's beta minus decay. So if a parent nuclei AZ undergo a decay to form a daughter nuclei and it emits a beta minus, the proton number will increase by 1, then an anti-neutrinos will also be produced. Because these particles have a range of energy, that actually is what actually first led to that particular hypothesis, which was then later confirmed that neutrinos and antineutrinos are produced whenever beta plus and whenever a nucleus undergoes that beta plus or beta minus decay. And I've explained that, you will see it in some other lecture, that it's because one of the up quark in a neutron changes to a down quark, and to balance the conservation of charge, beta plus will be produced. I've explained that. And whenever one of the down quark changes to an up quark, okay, during the decay of a neutron, one of the down quark changes to an up quark, then the beta minus will be produced. And I've explained that using the conservation of charge. And also, I have also said that during the decay of a proton, one of the up quark changes to a down quark, and that will lead to the emission of a beta plus. And I've also explained that using the conservation of charge. Whenever beta plus is produced, you have to expect the neutrinos should be produced. And whenever beta minus is produced, antineutrinos are also produced. So, for example, but you see that here, before I look at the example, you see that here we don't talk about gamma decay. Because what happens if I put gamma 00 here? Have I changed the composition of this decay? No. Because gamma 00 means that I did not change the composition there. But if I have a decay, if a parent nuclei changes to a daughter nuclei and it emits gamma particles, there will be no difference between the parent nuclei and the daughter nuclei. So we cannot call that a decay. But if I put gamma decay here, it doesn't change the nuclear reaction. What does that tell you? Gamma particles are often produced during the alpha decay or beta decay. If I don't put this energy here and I put plus gamma, does it mean energy is not produced there? The energy that are released there, they are now in the form of gamma photons. Take note of that. Okay? Take note of that. So, e.g., example, uranium 23592 undergoes 2 alpha decays and 3 beta decays. What is the proton number and nucleon number of the resulting nucleus? So I'm going to have uranium 23592. It undergoes 2 alpha decay, that is 2 alpha 42, plus 3 beta minus decay. So we want to know what Y will be. So I have 2, 3, 4, 8. So this will give 235 minus 8. That will give you 227. Then I have 2 times 2, 4. 3 times minus 1 minus 3. 4 minus 3 is what? Is 1. So I have 1 here. So this will be what? 91. 91. So the nuclear number of the resulting nuclei is 227. While the proton number is what? Is 91. Okay?